So this is the way. So you'll find that this second agent onwards, agent architecture is generally represented using a picture like this. Now this picture looks pretty explanatory itself. So this is the agent box that we were drawing already. There will be sensors for it, actuators or effectors for it, and there will be an environment. Now, some textbooks, this is called as an effector, कि ये वो effect देता है. Some people refer to it as an actuator because it gives an actuation. दोनों वर्ड सिमिलर है, दोनों में से कोई भी वर्ड आप यूज करोगे मतलब सेम होगा. Okay, since it is affecting the environment, it is referred to as effectors. Okay, actuation कर रहा है तो उसको actuator बोलोगे. Since it is delivering an action, actuator word use हुआ है कहीं बुक, बहुत सारे बुक्स पे. Some of the books and some of the teachers they prefer to use word effector. It doesn't change the meaning of it. Okay, now this was the question mark box. तो जो ये तीन है, 1, 2 और 3, ये तीनों मिला के मेरा वो क्वेश्चन मार्क वाला बॉक्स होता था. फॉर दैट आई जस्ट गो बैक टू माय सेकंड स्लाइड. 13 पेज पे मैं था. ये जो क्वेश्चन मार्क यहाँ पे आपको दिख रहा है, दैट क्वेश्चन मार्क इन दिस 13th स्लाइड आई हैव एक्चुअली कन्वर्टेड इट इनटू और डिवाइडेड इट इनटू 3 boxes. These 3 boxes are now taking care of my thought process as an agent. Okay, so what it is written over there? The first box actually asks a question. So it is trying to ask itself a question. What the world is like now? अभी मेरी दुनिया कैसे है? ये दुनिया word, this world word comes from the fact that we think of environment as the world view for that particular agent abstraction. So I'm trying to figure out what is the world like now. यानी outside world, मेरा environment अभी कैसा है? What is the world is like now? Now then the next question that this particular agent asks or tries to answer is, what action should I do now? So अगर world ऐसा है तो इस world में मैं कौन सा action करूं? So how do I describe the world's current placement? So current placement of the world or current representation of the world is represented using a state of the world. And using this state, I try to figure out using the condition action rules कि current condition क्या है. If I know what is the current condition, I will be able to, from the condition action rule, fetch the rule that tells me what action I can do. So see, now if we see the agent, I see both the things, it will be say smaller. So no, I'll see only this part. Maybe then we'll see the upper part afterwards. See, this is the program for simple reflex agent. Again, a percept is input, action is output. So we are using the same bracket. Now instead of 2 static variables, we say that rules नाम का एक static variable है, set of condition action rules. So these rules are condition action rules. अगर world का ये condition है, then you apply these set of rules to select an action. So this rules is what? Rules is actually representation of condition action components. So it's like a dictionary. Okay, it's like a dictionary that is being validated or that is being indexed using 2 indices. Keys are there, 2 keys are there, state and rules. So using state and rules, current state of the world and the rules, I try to match a corresponding rule of action. Okay, so ये rule क्या है? So rule is a data structure, okay, which is an index used in rule action table. So rule action नाम का एक table है जो ये particular rule अगर apply होता है तो ये action करना चाहिए, ऐसे defined होगा. And this is how our reflexes are defined ना. अगर मेरे say suppose I am near a fire and if my hand starts feeling heat, I'll take my hand out, right? If I'm trying to actually see that a ball is coming into my face, as a batsman, I will veer off my neck so that that particular ball passes me without hitting my face. Okay, so that is what we do as reflexes. And for doing reflexes, we do not give a lot of thought. We just see the ball coming. We just remember that previously जब ऐसे बॉल मेरे फेस पे लगा था तो मुझे ऐसे हुआ था तो इस सिचुएशन में मुझे क्या करना चाहिए आई नीड टू वियर ऑफ माई नेक सो दैट माई प्लेसमेंट ऑफ फेस चेंजेस एंड द बॉल passes me. Right? So this action that we perform is a rule based action. ऐसे हुआ तो ऐसे करो, ऐसे हुआ तो ऐसे करो. Okay, so it's a rule based action. To fetch a rule based action from the percept, first we define the state. Okay, first we define the state. What state the environment is in. From the state and the rules data structure, we get the corresponding rule out. So we get the corresponding rule out. So rule match and the rule action. This is what is happening in this box called as condition action rules. So condition action rules में ये दोनों step हो रहा है. We are just calling this function rule match to get the current rule, and using the rule index, we are getting the current action out from the rule action table. Please remember, we are fetching the first match. No further matches are sought, only one level deduction is done. That is, I find myself in this scenario, this is the corresponding action. But in the same scenario, I might have been in previous cases as well. लेकिन जो most recent hit होगा, वही rule में select करूँगा. That's the limitation of this particular thing called as simple reflex agent. They are effective in many scenarios to avoid many accidental situations, but they are also having a limitation. The limitation that they have is this condition action rule thing is again a fixed one. So what I avoided, अगर आप पहले देखोगे तो मेरे पास ये टेबल था जो स्टैटिक था. So now my table is not static. मेरे पास percepts थे. So I was building this huge data list called as percept sequence. Now I'm not building that. So I'm reducing my efforts in remembering the whole lot of previous percepts. But I'm still keeping this particular data structure called as rules. Okay, but rules is a not direct representation of percepts. It is some higher order representation. So we are actually trying to make this more sophisticated than the table driven agent. So now instead of saying that we are actually mapping every percept sequence to action, now we are actually collecting multiple percept sequences together and say that all these percept sequences belong to this state of environment. तो ये state of environment में अगर आप रहोगे तो आप ये particular action कर सकते हो. So what we are trying to do over here is we are trying to be more smart than building an entire table of infinitely mapping between percept sequences to percept. So we try to actually learn a pattern in percept sequences that are common. So we are trying to cluster out certain percept sequences together and say that these percept sequences belong to this particular condition. And depending on that, this rule should be fired up. And from that rule, we pick up the corresponding action. So rule is the index into this table called as rule action table. Okay. Again, though, this is going to be non-flexible. इसमें flexibility बहुत कम है. Okay, these are the problems. So table lookup of condition action pairs defining all possible condition action rules necessary to interact in an environment. Environment में work करने के लिए आपको ये condition action rules पहले से ही define करके रखना पड़ेगा. तो ये तो वही हो गया. मुझे पूरा टेबल के जगह पे अभी condition action rules पता करने. So I'm trying to reduce my burden of accumulating all set of percept sequences, but yet still I need to create a data structure called as condition action rules in advance before the agent starts interacting in the environment. If I do not have condition action rules defined properly, then probably some of the environment percepts, I will not be able to translate them well into the corresponding rule. I won't be able to fire the corresponding rule for that scenario. Okay, so that's a drawback of this particular agent type, or that's a thing, I should say, is a limitation of this particular kind of agent architecture. It tries to better the earlier architecture, but still, this is not a valid solution. Okay. Problems are what? Table is still too big to generate and store. कौन सा टेबल है यहाँ पे भी टेबल है, कौन सा वाला? रूल्स वाला, ये वाला एक्शन रूल्स वाला, रूल मैप टू एक्शन. ओके, दिस टेबल इज यूज. ओके, रूल मैच, ये भी टेबल ही है. ये दोनों टेबल बड़े हैं. हाँ, ये इतने बड़े नहीं है कि आप सभी परसेप्ट्स को स्टोर कर रहे हैं. सो यू आर ट्राइंग टू रिड्यूस द अमाउंट ऑफ स्टोरेज रिक्वायर्ड, बट स्टिल इट इज ह्यूज. Takes long time to build the table. So you need to have a lot of experience of solving that problem in order to understand that previous iteration में शायद मैंने ये rule consider नहीं किया था, अभी मुझे ये rule consider करना चाहिए. So as the environment changes or it actually adapts, you can adopt the things, but then for adapting it, you need to remember what was the environment like before and what it will be like now and what it will be in future as you impart your actions. Okay, no knowledge of non-perceptual parts of the current state. Current state को जब आप represent करते हो तो आप आपके percepts पे based उसका representation बनाते हो. You do not remember the part or the components of the environment which are not being reported through the percepts. So that's a limitation. This is again non-adaptive to changes in the environment, requires entire table to be updated if even small changes occur in the way the environment is interacting. Looping can't make the action conditional. So that is what I think. So you can't make any action conditional. ये करना चाहिए, नहीं करना चाहिए. So that is another concern with simple reflex agent. Okay. Now, to better represent the reflex agent or simple reflex agent, people devised an agent called as model based reflex agent. Okay, इसको reflex agent with internal state भी कहा जाता है. तो ये एजेंट क्या करता है? ये एजेंट और एक और एक persistent variable या persistent information store करता है. ये होता है state. This state is actually the previous state of the world. Okay, this is probably the previous state of the world. So initially this value will be 0. As the agent perceives first sequence, percept from the environment, agent will build the state of environment and it will store it in this variable called as state. Now this state, it will remember whenever it gets the next percept. Okay, at that time we will refer to this state as the previous state of affairs. Okay, so you are actually keeping this state variable now as a persistent variable. You will have this function over here. So state is there as description of the current state of the world. And this is a static variable. So you are remembering this across two calls to the function which is reflex agent with state or model based reflex agent. Okay, so पहला percept आएगा, मैं state variable build करूंगा. Second percept आएगा, मेरा previous state वाला value मेरे पास रहेगा. Okay, and I can use it. I can use it to do what? I can use it to do update the state. So I will be updating the state based on the previous state value, current percept, to get new state. नया state जो आएगा वो state rules use करके मैं rule match choose करूंगा. Now with this rule action, I'll get the get the requisite action out. Then again I'll update the state. Now this is what is looking like our skeletal agent that we were talking about. अभी तक का एजेंट सिर्फ एक्शन लेता था और उसको रिटर्न करता था, लेकिन ये एक्शन लेने के बाद भी स्टेट को अपडेट कर रहा है. एंड दिस इज वेरी इंपॉर्टेंट. So what we are trying to now do, we are trying to actually look at what was the previous state, current percept plus previous state. We are trying to predict the new state of the environment. So we are keeping a track of how the environment state is evolving over a period of time from previous instance to current instance. Okay, so we are not just based on just my current percept trying to model the state of affairs, but we are trying to see पिछले परसेप्ट की वजह से क्या स्टेट था, इस परसेप्ट की वजह से उस स्टेट में क्या चेंजेस हुए हैं. So we are now trying to represent or model the state of environment in a better approximation than previously. Previously, it was just an instantaneous look at the environment based on the percept and get the model. तो वहां पे क्या हो रहा था कि अभी मुझे जो पार्ट ऑफ द इन्वायरमेंट दिख रहा था उस हिसाब से मेरा मॉडल हो रहा था लेकिन एज आई हैव डिफरेंट काइंड ऑफ इंटरेक्शन विद इवन सेम इन्वायरमेंट एवरी टाइम I may get a different set of info from the percepts that I have. For instance, say suppose you are in a moving car and you are able to see certain part of your viewport because there is a other car in front of you. But after say 2 minutes passed, that second car is overtaken by you. Now what you see was blocked earlier. So your percept is same, the signal that I'm receiving from my camera. But since I overtook the car which was in front of me, which was blocking my vision, now I have a different state of affairs reported to me by the same percept. So I'm not changing the environment. I'm not changing the signal I'm receiving from the environment. But now I am in a different viewpoint or I am having a different point of view about environment because clearly I am in a different place and I am looking at from a different place. This also happens when you are passing through a particular train or something and you are viewing a particular thing at a different angle. As you go move in a different place, your angle of view changes and you get to see a different perspective, the same thing. This is exactly what will happen when you use state information as a persistent variable, as a static variable. So this is the description of the current world state and it is maintained or I should say retained across the next call. It is retained across the next call. So rule match and other things are same. I'm not going to explain it in further details today. So we'll continue discussing about the third agent architecture called as model-based reflex agent or a reflex agent with internal state. Okay, so this is the architecture and we'll be continuing this discussion in our next